Hello, everybody. My name is Daryl O'Bear, and I'm a technical marketer at Epic Games, primarily focusing on the enterprise space. Welcome to my webinar on Photoreal automotive rendering. Today, we're going to be focusing in on a few key concepts. We're going to be looking at how we can set your project up and get your data imported correctly. We're going to go over some lighting tips and workflows. We're going to show how you can work and optimize the hybrid ray tracer, and we'll finish off with a quick introduction to the render manager. So I hope you guys enjoy it, and thank you so much for taking the time to check it out. Cheers. All right, so this is the end result that we'll be working towards today. This is a project that I put together to launch the Automotive Material Pack, and we'll be using the automotive materials throughout this presentation. You can download the Automotive Material Pack from the marketplace, and it is revised with the engine, so make sure that you keep it current. The A5 Cabriolet was provided to us by Audi, and thank you so much to Audi for giving us your TrueCAD data. It's a real treat to get to work with such high quality assets. So let's go ahead and jump into the editor and start checking some stuff out. So the first thing that I want to talk about are some of the project-specific settings that I always use, as well as some plugins that I'm using in this project, and one very important CVAR or console variable that you're always going to want to turn on right away. So let's go ahead and check out some of the plugins we're using by going to Settings and bringing up the plugin editor. So I'm using the Sun Position Calculator. It's actually what's lighting my scene currently. You can see it here if we select it in the viewport. We're also going to be using the HDRI backdrop. And the final plugin that we're going to check out today are the virtual production utilities. So I have those three plugins turned on in my project already. So project settings, let's go ahead and talk about a few really important ones. So we'll bring up the project settings editor. And the first one that you want to turn on is ray tracing. So we'll just search for ray, and you can see that I already have ray tracing turned on. It's worth mentioning that many of these project settings require an engine restart. So I've already turned them on just to speed the demo up. Now, for ray tracing to work, you also need to enable DX12. So that's done by going to Platforms and selecting Windows, going to the default RHI and just selecting DX12, which I obviously already have done also. So with that done, let's go ahead and search for exposure. So there's a few exposure settings that you want to make sure are turned on, and depending on how you created the project or when you created the project, these may or may not be turned on. So it's a good idea to turn on extended default luminance range as well as the apply pre-exposure. The next project setting that I always change is the reflection capture resolution. And I always increase this to 1024 or 2048. And you might be saying, well, we're talking about ray tracing. Why do we care about reflection capture resolution? And it's actually really important because Unreal uses a hybrid ray tracing approach. What this means is you may, for performance, ask Unreal at a certain point to not trace a ray and to fall back to those reflection captures. So you're going to want to use best practices when setting up those reflection captures, and part of that is increasing the resolution to get good visual fidelity. And we'll be talking about reflection captures a bit more later in the presentation. So the next project setting that I turn on is the Enable Clear Coat Second Normal, and this one is really, really important. Let me show you an example of what this does. So here what we're looking at is the dash of the Audi, and I've used the Automotive Material Pack carbon fiber on this main gray bar, and it doesn't look like carbon fiber at all. And the reason it doesn't look like carbon fiber is in this render, Enable Clear Coat Second Normal is not turned on. So we don't get any sense of that weave happening underneath the clear coat. So let me show you an example of what it looks like once that flag has been enabled. So here we can see we get that normal information in the base substrate, giving us the weave with this beautiful clear coat layered on top of it. So the takeaway from this is if you're using the Automotive Material Pack and you're doing anything fancy with normals and clear coat, you want to make sure that's just turned on. So the next one that we want to talk about is atmosphere. There's several different project settings for atmosphere, and the atmosphere model was newly introduced into Unreal It's amazing. You want to make sure these are all turned on, including the effect height fog. So if you look at my scene, let's go ahead and close this down here. In my sun sky, you can see the sun sky is made up of the calculator for the compass, skylight, a directional light, as well as the sky atmosphere, which is actually driving all the color and the gradient that we see in the background. Now, I just added this to my scene by dragging it in from my lights. It's also worth noting that I have a post-process volume in here. This is just the default post-process volume. And I've got an exponential height fog also dragged in. Now, because I had that exponential height fog atmosphere switch turned on, the sky atmosphere has the ability to actually drive the scatter color of the exponential height fog. So you're going to want to make sure that you turn off any other additional contribution. You want to basically make the scatter colors black on that exponential height fog so that all the color information is being driven from that sky atmosphere model. That's basically it. So you can see as I change my solar time here, the background gradient changes because it's being generated by that sky atmosphere. All the lighting information changes and it looks pretty good. But what you may notice is the reflections look super, super soft. And you might think maybe it's not ray tracing. No, it actually is ray tracing. The reflections look really soft because of that important console variable that I said is like the first thing you want to turn on, basically. What's going on is the denoiser is softening those reflections. So we want to disable the denoiser. So how do you do that? It's super, super simple. To enable a console variable, all you have to do is hit the tilde key, and that brings up the command window down here at the bottom. So all I have to do is start searching for denoiser, and you can see that there is a reflection denoiser. Now this is a Boolean, so it's just a 0 or a 1 to turn it off. So what we want to do is we want to turn the denoiser off. And as soon as I do that, you can see my reflections got nice and crisp. Now it looks like it's ray tracing, which is exactly what we want. Now here's a cool trick when working with console variables. If I hit the tilde key one more time to bring it up, I can use the up and down arrow keys to jump through the last console variables that I've set. And you can see that I've played around with a few of these in this project. So if I wanted to turn that denoiser back on, all I have to do is, kind of arrow up to it and set it to a 1 state. And you can see now we have those super soft reflections. So let's just go ahead and get that turned back off. The next issue that I want to show you guys how to resolve is bad reflections due to low precision normals. So look at the reflection of this color calibrator in the door of the vehicle as I start to move it across the screen. You're going to see all this weird swimming and kind of waviness happening in the reflection of that color calibrator in the door. Also, if we zoom in, you're going to see a lot of this kind of stair-stepping and just really bad artifacting happening across that reflection. So there's a couple of areas where you will need to go to address this or potentially need to go to address this. And first is in the project settings. So in project settings, just search for buffer and go down to the G buffer format. And what we want to do is we want to change this G buffer from default to use high precision normals. So as soon as I do that, you can see all those gradients, they just clean themselves up and we're not getting that weird stair-stepping anymore. And I'll turn it back off just one more time so you can see, it just looks really bad, really gnarly. You put on the high quality normals and it just cleans it up. So let's jump back out to the reflection on the door and I'll start to move the car across the screen here. And you'll notice that even though our G buffer has been set correctly, the door still has an issue. And the reason that's happening is because on the geometry level, there's actually an attribute that you may or may not need to turn on. So let's go ahead and bring up the static mesh editor for this door and check that out. So in the door, you can see there is another attribute for high precision tangents, and you want to make sure that this is checked on or turned on. Now, depending on how you imported the geometry, this will be on or off. So if you come in from FBX, that's probably not going to be on. But if you bring your geometry in through Datasmith, this high precision tangent basis is going to be turned on by default. So just keep that in mind. So you need to do two things. You need to turn it on, and then you need to click the apply changes. So now that we've done that, as we start to move across the screen here, you can see that color calibrator is no longer swimming and doing, that really weird wavy pattern. So it just really goes in there and totally cleans up all the reflections for you and makes them look correct. All right, so now that we've got the basic project settings sorted out, the next thing that we want to do is improve the look of the vehicle. Specifically, these headlights we're going to start with, they're really dark. There's not a lot of pop or sparkle happening in them. So to address that, I'm going to change a few of the ray tracing attributes. Now, there's a couple places you can do this. You can set the ray tracing attributes using CVARs, similar to what we did before, or you can set some of the ray tracing attributes using a post-process volume. It's worth mentioning that you can have more than one post-process volume in your level. So you might have one that covers the interior of the vehicle and a second post-process volume that takes over when the camera's outside of the vehicle for the exterior shots. So that's a super powerful feature. Now, in my level, I've already got a post-process volume added, and I've changed a couple of settings. So in the post-process volume settings, I've got the infinite extend checked on. That just means that this post-process volume covers my whole scene. And let's jump into the rendering features to start to dial in these reflections. So we're going to go down to the ray trace reflections, and we're going to change this max bounce from 1 to 3. And as soon as I do that, we've got 3 bounces inside of the lights. They start to have a bit more pop or sparkle on them. And we obviously have reflections of reflections happening across the tail of the car with this kind of chrome ball on that kind of, color calibrator, but it still doesn't look exactly the way I want. The headlight's still a bit dark. So the reason this is happening is after this third bounce, what happens is the ray tracer falls back to black. And I want to change that. And fortunately, we have a CVAR that allows me to modify that behavior, that default behavior of hitting black as the end color, and have it fall back to your reflection captures or your environment. So again, it's a very simple process to set a CVAR. Just hit the tilde key to bring it up, and I can use my up and down arrow keys to jump into my list of recent commands that I've used in this project. So I've already used this before, that's why it's here. And the CVAR that you want to set is r.raytracing.reflections.reflection captures. It's a Boolean, so if we put that to a value of 1, you can see that instead of falling back to black, it falls back to that skylight that's got that procedural sun sky kind of gradient driving it. So it looks a lot better than falling back to a value of black. So that looks pretty cool. Now, the next thing that we want to do is modify the way the glass is working. Right now, it's using the default translucency model of raster. So we can change that in the post-process volume by opening up translucency and just switching that over to ray tracing. And that looks a bit better. Now, this is a pretty simple scene that we have in our environment. That change would have been a little bit more dramatic if I had something that was more complex in the scene. So how do you get a more complex environment? Well, it's really easy to do using the HDRI backdrop. So let's go ahead and jump over to my levels and turn off the level that's got this procedural sun sky in it, so my basic lighting level, and let's light this vehicle using that HDRI backdrop. So we'll just drag and drop that into our viewport. And with that added in, the next thing that we're going to do is we're just going to drop that down a little bit lower so it's below the level of the parking lot there. And this looks pretty good, but it's a little bit dark. So we're going to brighten it up by going and adjusting my exposure, my EV. Now you'll notice that I have game settings turned off. When I'm lighting a scene, I almost always disable the auto exposure or the eye adaptation by turning off game settings, and I manually set an EV to dial in that lighting. Now later in the project, I might go in there and turn that on and further refine it or tweak the values that uses in the post-process volume. But when I'm doing my initial lighting, I almost always turn that off. So to brighten this, we'll just drop that down to a minus 0.5, and that starts to look pretty good. Now with this default image that came in with that HDRI backdrop, it's pretty diffuse, and it does a decent job with the default settings of capturing the overall lighting and look of this vehicle. Now, if I had an image that was used that had a bit more contrast, like a nighttime image with some street lights or a really bright sunny day with no clouds in the sky with a lot of contrast, to capture that detail, I might need to change some of the default settings on the HDRI backdrop to capture that high contrast image. So let me show you what that means in context. So let's go ahead and just select that HDRI backdrop. We'll go over here and we'll switch the image over to another one that ships with Unreal, which is this really bright day, just a sunny day with no clouds in the sky. And this looks a little bit dark. So let's just go and Let's just do like a -1 on that guy and kind of brighten it up a little bit. And you can see that this is capturing the directionality of that sun, but it's a little bit soft. I think that the shadows should be a little bit crisper. And you can really see that if we go in here and look at this in lighting only mode. So to modify that, what we're going to do is we're going to just kind of pull this down a little bit here. You'll notice that part of this HDRI backdrop is a component of a skylight. So if we grab this skylight and we increase the resolution up to 1024 from 128, you can see that it really crispens that shadow up, and that starts to look a little bit better, a little bit more consistent with what you would expect from that sun. Now, the next thing that you might want to adjust on the skylight is another attribute that adjusts the overall quality of it, and that's the samples per pixel. Now, this is something that you're going to basically dial in based on your scene and based on the images that you're using. And what you're trying to do is balance performance versus visual fidelity or lack of noise. So if we go ahead and turn on our frame right here with the default settings, we're right around 9 milliseconds, 10 milliseconds. And if you had a lot of noise that you were picking up from that skylight, you might want to increase these samples. And you can see if I, push it up to something like 16, yeah, it's going to look better, but I've also, lost 7 or 8 milliseconds there. So it's going to be one of those attributes that you're going to really need to balance specifically to your project based on, what you're trying to do, speed versus quality. So I'm going to just pull that back down to something like 6 just for this example. And that starts to look about right. So now that we've done that, the next thing that we want to do is start to use an image that I added into the level, that one that we started off with the video. So let's go ahead and check that out. All right, so let's go ahead and jump back into the top level of that HDRI backdrop, and we'll map in the image that was in that original video. There's a couple things I want to talk about with HDRIs when you bring them in. So first thing, make sure that sRGB is turned off. It should be by default. Also go down to the level of detail and turn off the MIP generation settings to have no MIP maps. And finally, you're going to want to increase that maximum texture size. For my example, I'm running at 4096, and you'll have to expand that out to get to that attribute to change. So with those few things set, and make sure that you do this no MIP mapping first before you change the resolution, because that'll speed the process up greatly, because it's not trying to generate a whole series of MIPs down from 4096. With all that done, you'll be ready to roll with your own HDRIs, which is super cool. So when you bring your own HDRI in, the first thing that I like to do is I like to find an exposure value that really captures the overall feel of that image. And then I'm going to try to match my CG lighting to that. So you'll notice that when that exposure level is at 0, this looks pretty good. It might be a little underexposed, but I'm going to roll with this for my base lighting. And you can see that the CG elements are a bit darker, especially like the backside of this building versus the backside of this concrete wall. So whenever you're working with HDRs, there's who knows how many brackets they used when they created them, or what they did in post, or what the overall luminance is. So there's probably going to be some chances that you need to adjust the amount of light versus the overall background image. And that's easily done by just going into the skylight on the HDRI backdrop and just increasing its intensity. So I'm just going to push that up to like a value of 2 to try to get those guys to kind of better match and ground with each other. And that starts to look pretty good. Now you'll also notice that as I move around here, that dome is just way too small. There's actually lots of things we want to change on the dome. So we're going to go back to the HDRI backdrop, and we're just going to increase its size out to something like 600. And when I do that now, you can see that rock wall kind of just grounds in there and looks pretty good. You'll notice that there's some hazing happening on that ground wall. That's because I've got a sky atmosphere in my level as well as this exponential height fog. So very similar to that sun sky system that we used to light the scene at the very beginning of the demo. So a couple of other things that we want to do, the projection's a bit off right now, so the waves are way too close. So you could either grab the projection node in the viewport and use that to recenter the image, or you can just manually pump in some values here. So if we put that up to like 500, those waves start to look a little bit better. Now the next thing that I'm going to do is I'm going to turn off this lighting distance factor. This is used to have shadows from CG elements drop on top of the ground of the dome, but since we're kind of using this parking lot, we don't really need that effect. So I'm just going to kind of zero that out. So the final thing that I want to do is I want to change the orientation of the dome. Right now it looks like the sun would be kind of streaking across the nose of the car, and I want it to be kind of backlit across the tail of the car. So all I'm going to do is just take the dome and spin it around the Z -5. So that starts to look pretty good. Now, when I'm working with HDRIs, I almost always add in a directional light just to give me control over how strong that sun would be. I really wanted this scene to have like a big sun sitting over here with like this really strong warm light washing across a car with like long soft shadows. So that's easily done. Like these creative decisions are easily made inside of Unreal just by simply dragging and dropping a directional light in the scene. So once that kind of comes in, we'll display that light. What we want to do is we want to, first of all, make this movable. And then the next thing that we're going to do is we're going to kind of just position it over here near this little color calibrator. And I'm going to essentially make my scene, pretty dark so that I can kind of see what's going on with my sky in that chrome ball. So I'll kind of zoom in on that chrome ball. And really what I want to do is I want to get this light to sort of just position itself, kind of where you think it should be. So kind of low in the sky, kind of coming across the horizon there and just sort of streaking across. And, I can kind of fudge this a little bit and, make some creative choices to kind of do what I want with that, which is pretty cool. Now let's go ahead and get this back to a value of 0. So that starts to look, looks pretty good. I get these nice long shadows sort of coming off. I might rotate it this way a little bit more and maybe make it a little bit lower in the sky. Now, the next thing that I want to do is I want to change the tint of this. So right now it's not colored correctly. So what we're going to do is there's a couple ways of adjusting the color of the sun. You could use temperature and, put this to something, nice and warm, like 4,000. Another way of doing this is to not use the temperature, but let the sky atmosphere drive the overall color of the sun. And this is easily done when you have the directional light selected. If you just search for fog or even search for atmosphere, you can turn this switch on, and that's going to color the light based on the kind of the direction of the light and the sky atmosphere that it's passing through. Now, keep in mind that if you wanted to overdrive that, like with user temp, you could do that, right? Like you can go nuts and kind of make non-realistic results, but things that still look very visually pretty, by changing some of these default values or some of these default things, by layering these two guys together. I'm just going to add in a little more warmth and that looks pretty good to me. So the next thing that we want to do is kind of play around with the shadows a bit and in the shape of this light a bit. So right now it's got the source angle set to 0.5 or around 0.5. I want to have that be a little bit softer, like it's passing through the low atmosphere with lots of cloud layers in there. So I'm going to soften this up a bit more by putting that to a value of like 2. And you can see that those shadows get really nice and soft now. And you get this nice ray trace effect where they're like crisp near the tire, and then they just kind of fade off into this, soft look for objects that are further away, especially all those railings. They kind of just blur out into nothing, which I think looks pretty good. So the next thing that we want to do is I just want to also increase a little bit of source angle into this just to kind of soften that effect and kind of streak that sun out down the door ever so slightly. So that starts to look pretty good. Now, the next thing that we're going to do is I always change the bloom. So if we go into the post-process settings and we go to bloom, I'm going to switch this method over from standard to convolution. Now this does, it comes with a performance hit. It's a few milliseconds, but the overall effect just looks so good. I think it's really worth it. So you get that really nice little kind of, star pattern happening on the bloom of that sun. And if it's a little strong, you can always go into the advanced section, and in the advanced section, go down to the multi-boost and just drop that guy down to something, cut it in half, maybe something like 0.8 might reel it in and make it look a little bit better. So that starts to look really, really pretty awesome and pretty cool. So the next thing that I want to talk to you about is the effect that happens when the sun kind of gets occluded by like this A-pillar. So right now, nothing is really happening that's very strong here. And with that sun, right? Like if we go ahead and we turn off the HDRI, and I might actually lower the sun in the sky a little bit more. Let's kind of get it down sort of like that. so that it kind of burns through this guy. You get this really nice little, like that little bloom effect thing happening there as it kind of bleeds through that A-pillar. But when we turn on the backdrop, it just goes away. So that's not cool. So how do you fix that? Well, it's actually really simple. So if we go back into the HDR backdrop and go into the geometry for that and go to the material, and we're just going to double click down until we get to the master. We're going to modify this master material. So what we want to do is we want to add in that sky atmosphere. So if you right click and search for sky, you can see that there's several nodes for working with the sky atmosphere in the material editor. So we're going to grab this sky atmosphere light disk luminance, and we're going to add that into the emissive color of that HDRI backdrop material. So if I hold down the A key and click with my left mouse button, it's just a quick key to add in the add. Like if you hold down 1 and click with the left mouse button, it does a float, 3 does a vector, M does multiply. So there's lots of little hotkey workflow things in this that are super cool. That's another story though. So we're just going to add these two guys together. So emissive color and the sun disk basically piped into emissive color. So just like that, if we hit apply, we can save it out too. It doesn't really matter. You can see we've now added that effect in, so we get this nice little bloom effect happening as it passes by that A-pillar, which is just so sweet. Really, really looks awesome. So the next thing that we want to do is I want to add in like some light shafts, like some little subtle light rays. So how do you do that? Well, that's again pretty straightforward. If you go to the directional light and you kind of scroll down here, you can see there's this whole section for light shafts. So if we turn on light shaft bloom, nothing happens. You're like, oh man, why did anything happen? Well, nothing happened because that dome is kind of interfering with everything. So to work around that, if you turn on light shaft occlusion, these attributes are no longer grayed out. And if we just drop this occlusion depth range down to something smaller than the dome, so something like 5,000, you can see, well, they're your light shafts, and man, those are strong. So let's tone that down. You can go to a value of 1 or maybe even 0.1 on this. And, like if you want it to be really subtle, you can go 0.05 or, like you can kind of just dial this into where you want it, where you get these little light shafts, kind of happening there. You can kind of see that streaking light shaft happening, kind of those little God rays sort of kind of coming through there. And, that starts to look, really pretty nice and pretty sweet. And all in all, this is starting to look better. I mean, we still have a ways to go, lots of things to fix and lots of things to do, but it is starting to look, a little bit better. So how do we make the car look better on the dark side? Well, this is easily done again with adding in more lights into the scene. And I've actually already got a bunch of other lights that are added in here. They're just turned off. So we're going to turn all those lights on. So I've got a couple on the headlights. I've got some, adding some brightness into the interior, and running along the side of the car, I've got this really big rectangle light, and you can see that it's giving me this really broad specular highlight. And that might look good if you were in like a photo studio and trying to do a physical light, but on this exterior shot, that just doesn't work for me. So what we're going to do is we're going to, on that rectangle light, search for spec, and we're going to zero that out. So it's kind of like just a diffuse light now. And I'm going to overdrive the intensity of this so you can see what's happening with it. So it's brightening up the car, and it's also, brightening up the ground plane. That might be a little bit much. Let's tone that down. So really what I want to do is I want to have this, oops, it looks like my spec got turned off. Let's go back to that guy and zero that back out. What we really want to do is we want to have this only brighten the car. So this is done with lighting channels. So if you search for channel on a light or on a piece of geometry, you can see that lighting channel 0 is the default lighting channel. So if I turn that off, this light's affecting nothing in the scene. If I turn on 1, it's only going to affect geometry that has lighting channel 1 enabled. So if we select this ground plane and we look at it, you can see that it only has lighting channel 0 affecting it. So if I hit 1 on, that light now starts to contribute its effect to that piece of geometry. So we don't want to do that. And of course, obviously, if we looked at the pieces of the geometry on the car, they're getting hit by 0 and 1. So that gives you the ability to do really kind of basic light linking inside of Unreal. And you have 3 channels to work with. So we'll just drop this down to 20. I just wanted a little bit of boost on that. And I'm doing the same thing with the wheels. Like I'm popping in a little bit of brightness into the wheels and a little bit of brightness into the interior, but not hitting the ground plane. So it lets you start to do these kind of fun things. which is really, really awesome. It's really good at that type of stuff. All right, so the next thing that we want to talk about is the car paint. So right now, the car paint is using the clear coat. The clear coat's had a lot of work done to it in 4.25. It's awesome. And this car paint, I've actually got all the bells and whistles turned off, or most of the bells and whistles turned off, because we were trying to look at all the, kind of the normal issues and things like that. So I'm going to just walk you through turning on a few of these and a few of the parameters that I always change from the default. So if we just double click on this guy and we sort of bring it over here, the first thing that we're going to look at is the roughness, the min and max roughness. So if you put these to the default values, it's going to go through and it's going to really kind of soften the effect of that on those glancing angles a little bit more than I like. So I normally drop this down to something like 0.015 and, like 0.04. And if I'm trying to get 0.04. If I'm trying to get some metal or some swirls in there, on that light or something like that, if you pump this max roughness up to something like 0.3, you can start to get, that little break of that speck, those little kind of sanding marks or like bad detailing marks inside of there. That might be a little bit too strong. 0.025 starts to look a little bit better, and it just kind of breaks up that specularity. So those are a few of the values that I play with on the max roughness. Now, another one that I always like to do is let's get the metal flake back on. So you just kind of get that nice little subtle metal flake inside of there. I didn't really change any of the values on that normally, but I do go in here, and for the orange peel, I've got it zeroed out. The default value of 0.05, it's good, but I think it might be, for my taste, it's just a little bit strong. So I normally drop that down to like 0.03 or 0.04, something like that, just to still have a little bit of the peel in there, but it looks like it's a higher quality paint job, baby, or something like that. So those are a few of the things that I often change, on that to get the overall look inside of it. Another thing that you're going to notice right here is you can see these shadows kind of on that car, and they're hard shadows. So how do you fix that? Well, that's, again, something very easily done in the post-process volume. So if we go back into the post-process volume, I've got a bunch of stuff open now. Let's just kind of close those guys back down. And you go into the ray tracing section on this guy for ray tracing reflections. And you switch your shadows from hard to area shadows. You can see that those kind of fade away as you would expect because they were faded away over here. So little change, but makes a big difference in the overall look and feel of the vehicle. All right, so the next thing that we want to talk about is ray trace optimization and the material level and what the Automotive Material Pack is doing, and a few things that I've modified to give myself more control. And for this particular project. So hopefully you guys like this. So optimization at the material level. So there's a ray tracing quality node. And what that does is it allows you to do a couple things. So let's go ahead and jump into, I'll show you this in a practical example here. So let's jump into the material, and we'll jump into this master that I made, and we'll just expand this out a little bit. So we've got this ray tracing quality. And what this does is it allows you to say for the kind of primary ray or the camera ray, do something, and then for the bounced ray or the reflected ray or the ray traced ray, do something else. So certain things are going to be faster if you optimize them to do a more simplified calculation, like roughness. For the ray trace reflections, if the roughness is 1 or 0, they're going to be faster than if there's like a broad highlight that they have to you can kind of deal with, and you have to kind of fight noise and reflections and things like that. Another example would be the lighting model. For the ray trace lighting model, you might want to just go for the default lit as opposed to something more costly for the reflected version of it. Same thing with normals. You might just want to get rid of those. And that's actually what the Automotive Material Pack is doing. So let's see what this material does on a simple object, just so you get a really firm understanding of what this little ray trace switch node is doing. So if we jump into basic, drop a sphere in our scene here, and with that done, we can just go ahead and drag and drop this on that. So you can see, obviously, the primary ray is different than what the bounced reflection is doing, or what the bounced version of that is doing. So the ray trace version of that. So that's what it is in a nutshell, and it allows you to basically gain slight performance where things would be more costly. So let's go ahead and look at the Automotive material pack setup and what they did, and then how I've modified it or changed it. So we're going to grab this mirror, and on this mirror, we're just going to kind of jump in here, and we'll jump into this master. And this is my master that I kind of modified here. So the default master basically had this material function called bounce rough. And if we look at what the default master used to do, it's pretty straightforward. Like it would come through and it would basically be like, all right, here's your original material. And that's fine for the normal, you know, like the camera ray or the primary ray. But for the ray traced ray, we're going to come through and we're going to branch out roughness, and we're going to set that to a value of 1 for every single material in the Automotive material pack. We're going to turn off the normal, and we're going to put it to default lit. So it's a few little things that happen, and it gives you a slight performance increase. But with this comes basically incorrect results, right? Like you're sacrificing quality for performance, like most things, right? Like that's always the balance that you're playing with real time and Unreal. So in certain examples, you know, like the performance difference to get the highest quality isn't going to be a crucial factor, right? Like you might want it and you're willing to take the hit, right? So what I've done is, if we go back to this, you can see here's what I've done is I've taken that same function and I've broken it out so that I'm still killing the normal, I'm still leaving default lit, but I just made this an attribute that I can adjust, a parameter that's been exposed that I can adjust. So it's not just hardwired to 1. And I've also added in a simple little switch that basically says I can turn on and off this bit of logic right here, this ray trace optimization. I can basically say just ignore it, right? Like it's basically it's just a straight wiring in of the original material. So let's see what that means in context. Let's go ahead and jump in here and look at this. So this mirror is actually a perfect example of where you wouldn't want to use the optimization, because this is a very incorrect result. We would expect this mirror to bounce back and reflect like the sky or something like that. So if we grab that mirror and we look at this material, because I've modified the master. So this is something that you won't have in your Automotive material pack, is this exposed parameter ray trace roughness. That was from that modified material function that I made. So look at what happens when I put this down to 0. You get this reflection of the sky, you get the reflection of the A-pillar kind of coming into it, or the headrest. I'm not exactly sure what that is, but very different result than when it was at 1. And the speed difference is going to be super minimal, right? And sometimes you don't care about the speed difference. You're doing offline rendering with the new render manager and you want maximum quality. So the ability to, adjust that is for me was important for this project, right? So let's look at another example where we're going to bypass the material altogether. And that's going to be on this carbon fiber, right? So we kind of look down this carbon fiber, you get this kind of glancing angle down this carbon fiber, something like that looks pretty good. And if we go in here and we double click on this and we bring this up and we put this down to a value of 0, you get a reflection of a reflection, which is cool. You get the sun bouncing off of it, like drastically different look, right? From the default where you weren't allowed to adjust it, to me just saying, let's put that to something a little bit, more appropriate for what that carbon fiber would be. Now, here's the interesting thing. When I turn off the ray trace optimization, because this carbon fiber, a lot of that look is being driven from the clear coat with the under normal, it's going to change drastically, right? If I turn that on, you can see now you get the weave happening in the reflection of the reflection. So it's a perfect example of where you'd want to turn the optimization off altogether, right? Super, super different. You can see it up here reflecting in the chrome too. So if you go through and do this on every material, it is going to change the look and feel of it, a fair bit. So just keep that in mind. You have the ability to always take what ships with those content packs. And if you want to add your own little bit of logic or your own little bit of flavor on top of it, go for it. That's what I did for this project. So the next thing that we want to talk about is how to work with reflection captures. And we mentioned that they're important at the beginning of the presentation, and this next portion will kind of show you why. Let's check it out. Now, there's a couple of other things that we want to start to talk about, and that is reflections and the hybrid ray tracer. So we kind of alluded to that a bit earlier, and we never really finished the conversation. So if you look at this right now, things are looking good, but this wheel feels really, really off, right? So right now what's happening is with the hybrid ray tracer, the default max roughness value in the post-process volume is set to 0.6, okay? So what that means is any pixel that's got a roughness value lower than 0.6, which honestly is the majority of pixels in my scene currently, are going to use the ray tracer to calculate the reflection. And any value that is above 0.6, or any material that has a value, or any pixel that has a value above 0.6, is going to kick back and use the reflection captures to calculate what that reflection should look like. So that's what's happening on the wheels, is it's using the reflection captures, and that doesn't really look realistic. So the cool thing about this is it really does let you fine-tune the visual fidelity versus performance, because in lots of examples, you're not worried about maximum frame rate. You might be creating an EXR image sequence or a giant still, and you just want the maximum quality, and you can get that by just setting your max roughness to a value of 1. We're now ray tracing every single pixel regardless of how rough the surface is. And it looks cool. And it costs us like 4 milliseconds to do that, but it also introduced in some noise. So if you wanted to clean the noise up, you'd have to start to increase your sample. So if we go up to 5 samples per pixel, it cleans up the noise a bit, but we're around 40 milliseconds now, right? So that's not good. So let's just drop this back down to 0.6 and let's try to make it look a little bit better with reflection captures. So why is it bright? Well, the reason it's so bright is right now there's only one reflection capture in my scene. It's that sky that was a part of the HDRI backdrop. So it's basically falling back to the sky color. So what we want to do is we want to add in some reflection captures that are going to better capture the overall environment. And I've already set a lot of those up in my scene. So let's just go ahead and turn those guys on. And if we kind of zoom out here, you can see I've got a big one going down the side. I've got one on the hood. I've got, little spheres over in these nooks and crannies on the headlights. And then wrapped around each wheel, I've actually got a reflection capture sort of centered on the wheel. And what I'm going to do is I'm actually going to go in and I'm going to push off where that reflection capture is actually going to get rendered from, that spherical reflection capture. I want to push out a little bit from those wheels so that it actually gets a bit of the environment in there. So what we're going to do now is we're going to go ahead and we're going to build the reflection captures. And what's going to happen is it's going to surprise you. So we hit build, it goes through, it calculates all these reflection captures, and boom, nothing changed. What the heck? Why did anything change? If I grab this reflection capture, normally if you start offsetting one of these guys, you'd see the reflection moving around. So the reason nothing happened is because of an issue with the way the HDRI backdrop comes in. So how do you fix it and what is the issue? So let's go ahead and select that HDR backdrop actor and grab this skylight, and you'll notice that there's a parameter called sky distance threshold, and it's set to 1. Incorrectly, I should say, it's set to 1. If we drag a normal skylight out, you can see that sky distance threshold is set to a value of 15,000. What that value does is it measures from the point of that skylight out in units, and anything that's within that, lower than that range is going to be considered part of the sky. So at a value of 1, basically all of my geometry in my scene is part of the skylight. So it doesn't, the reflection captures never work. They don't get evaluated at all. They don't even get calculated. So what we need to do is we just need to increase that up to something like a value of 6,000, something like that. And then we're going to go ahead and we're going to say build reflection captures one more time. And once we do that, you can see just like that, now it looks a whole lot better. It gives you the result that you would expect. And of course, if I grab this and start moving it, you can see that's that reflection capture offsetting on that wheel. So if we go back into our post-process volume here and we grab this guy and we just look at what's going on, you can see that at a value of 0.6, it looks pretty similar to what it looked like at 1. If I put this up to a value of 1, they look almost the same. And if I go down to something, but the frame rate's bad. Like, look, my 42 milliseconds. So if I put this back down to something like 0.6, the tire gets a little bit brighter. And that's mainly because this reflection capture is not really covering that tire quite as much as it probably should be. But the wheel and the brake actually look good. And we're back down to 20 milliseconds. So that is why you need to still work with best practices when you're using the hybrid ray tracer you still need to do best practices for your reflection captures and reflection probes and things like that, so that when they kick back to them, they look super cool. And the end result now is, something that looks, really, really sweet. So the next thing that we want to do is we want to basically sweeten the lighting a little bit. It looks a little bit off to me. So I want to get a little bit more punch in this, and it's kind of washed out underneath the car. So I'm going to use the color correction volume that's part of the virtual production utilities. So make sure your view plugin content is on, and come over to your search path and just search for CCV. Jump into that folder and drag out the blueprint color correction volume. So with that added to our level, you can see that it's actually casting shadows into the environment. So let's go ahead and search for hidden, and let's just hide this actor in the game so that those shadows do not show up. So even though it's hidden, the color correction still works. So you can see as I move this gain around, I can still start to introduce a level of color correction. So all we really need to do is just drop this down. Now I'm going to switch the shape of this. Instead of being a sphere, I want it to go ahead and become a box. And I'm going to just kind of increase the scale of this guy. What I want to do is ultimately, I want to have this color correction volume just be a small sliver that's going to sit underneath the car to really make it feel planted or grounded. So I'm going to increase the level of the outer value here just to kind of blow that up a little bit and give it a little bit more fall off. And I'm just going to now position that underneath the car. And by doing this, you can see that it just kind of starts to make it feel a bit more planted underneath that car, and I think it just looks a little bit nicer. So now that we've done that, the next thing that I want to do is modify a couple of attributes in the post-process volume to give this a bit more punch. It still feels a little flat to me. So let's go ahead and pull up the post-process volume, and the first thing that I'm going to do is I'm going to change the bloom model. So instead of using the standard bloom for automotive stuff, I always like to switch over to the convolution, and that's going to give it this really nice little kind of star effect where the sun's hitting. And this does cost a few milliseconds, but I feel like it's really worth it because that overall little bloom that you get just looks so nice and so realistic. So the next thing that I want to do is I want to add a little more kind of punch to this. So I want to make it a little more contrasty. And an easy way to do that is with a LUT. So I'm going to go down to the color grading into the miscellaneous, and we're just going to add onto this a color LUT. And if I just search for LUT, Unreal ships with a couple. So I'm going to grab the LUT afternoon. And that's a little bit strong. I don't want quite that extreme of an effect. So I'm just going to drop down the intensity of that LUT to a value of 0.2. And you can see now, let's go ahead and just hide all that. You can see now that we've got something that's starting to look really pretty nice. So let's close that down and jump into our camera sequence. So this is what the end result ends up looking like. And what I want to do is I want to output a couple of these clips using the new Movie Render Queue. So go to the Windows, Cinematics, Movie Render Queue, and inside of here, we can use the Movie Render Queue to do a couple things. It can be used to generate extremely high resolution stills with a tiled rendering workflow, or it can be used to render out sequences, multiple sequences kind of stacked up on top or queued up on top of each other. And the rendering will render out sequences of images that have the ability to have multi-frame anti-aliasing as well as multi-frame motion blur. So I'm just going to click the plus button to add in a couple of cues here. So we'll just go and we'll grab, we'll just grab this first one. We'll just grab the Auto Master, and I'm going to add onto that this back turn. So once you've added a couple of sequences, the next thing to do is to set up the options that you want for the output. So you can make your own custom output options by selecting from a variety of different attributes, or you can use a preset and save your own presets actually. So these are two presets that I made. We'll just bring on the motion blur. So motion blur is going to be a PNG sequence with the anti-aliasing set to do 5 spatial samples and 3 temporal or motion blur samples. And I'm turning off the temporal anti-aliasing because of the count of samples that I have here, which is pretty awesome. And then for the output, I'm basically going to render out just a 1920 by 1080 image. So pretty straightforward stuff there. So with that done, we'll go ahead and we'll say accept. I'm going to do the same thing for this. We'll apply the motion blur setting. We'll say accept, and I'll just go ahead and fire off a render. So it's going to render out both sets of camera sequences, which is really pretty awesome. So I'd like to thank you guys for taking the time to watch my seminar. I hope you guys enjoyed it. We were moving through stuff really quickly. I know that a half hour is not a lot of time to talk about some of these concepts, but I hope you guys enjoyed it. And thanks again for taking the time to check it out. Cheers, everybody.